given the vector equation, n vector plus g vector is equal to 24.00 times a vector, and that the components of each of those vectors are n sub x is equal to 0, n sub y is equal to x, g sub x is equal to 240 times the sine of 5 degrees, g sub y is equal to minus 240 times the cosine of 5 degrees, a sub x is equal to y, and a sub y is equal to 0. Solve for the variables x and y as given. Now, this is very convoluted looking, but believe it or not, this actually corresponds exactly to a kind of physics problem we're going to wind up solving about a chapter from now. I'm not going to necessarily talk about what that problem is, and we're going to be using different symbols by the time we get there. But again, the kind of mathematical techniques that we're going to apply to this are going to be very, very similar. So this is a skill I wanted us to already get our feet wet with. So the technique here really is we got this kind of crazy looking vector equation, n plus g equals 24 times a. I mean, I think all the like 0.00 and that's all there for sig figs, and it looks like everything is kind of at a 4 sig fig level. So that's just telling me where we're going to round at the end, I think. But if I want to say, like, what do I do with this? Well, I'm going to write down the component equation. So if I see the vector equation, that's my guide for figuring out, like, what might the x component equation look like. So I'm just writing down the n sub x to replace the n vector here, plus g sub, oops, make that look more like a g. G sub x is equal to, and maybe it's cool if I just write the number 24. We'll just remember the number of sig figs times a sub x. And that's going to be the horizontal component of this vector equation. And then, you know, maybe I could jump right in right now and already start doing something with it, because I can make the replacements. I can see that 0 is there for the x component of n, and then for the x component of g, we've got this kind of crazy looking 240 multiplied by the sine of 5 degrees. And I'm going to leave out all the extra placeholder zeros because I'm just remembering that tells me something about sig figs, but to make my work a little bit easier, I'm leaving them out. And then on the other side, we've got the number 24 multiplied by a sub x, but a sub x is equal to the variable y, one of the variables we're being asked to solve for. So that tells me that y, if I divide both sides by 24, y should be equal to 240 times the sine of 5 degrees divided by 24. And I could put that into my calculator. Maybe I could also recognize that this would just be the same as 10 times the sine of 5 degrees. But either way, my calculator can handle this. And my calculator says that this is equal to like 0.871557, etc. But let's see, we're working out like what, a 4 significant figures we said. So that's like 8.871, and then I'll round off this one to a 6, I believe. Okay, so that gives me y. All right, we still have to solve for x. I bet you that one's going to come up somewhere in the horizontal component. So if we do a horizontal component equation by taking the same vector equation as a guide and saying, okay, let's write it with the horizontal components. I feel like I need to practice writing g's in this thing a bit more, but anyways, there it is. Time equals 24 times a sub y. And now we're going to do all the substitutions. So we got the x in there right away for the n sub y. We were hoping that would come in, right? G sub y is actually equal to a negative 240. Maybe the way I've written that there, just to make it clear, I'll put some parentheses on that, times cosine of 5 degrees. And since a sub y is just equal to 0, I mean, this is like 24 times 0, but maybe I could even just say, hey, that's 0, really. So if I want to solve for x, I think all I got to do is add this term to both sides, and I would get x is equal to, when I add that, since it's a negative term, I'm going to wind up, or adding the the positive version of it, I'm going to wind up with positive 240 times a cosine of 5 degrees, and that's something I can have my calculator do as well. And rounding that off appropriately, I get 239.1 for that. So my two answers, let me box my two answers. The solution for the variable y is there. The solution for the variable x is there. Just to be clear, to see if it aligns with what The slide says it should be. It looks like we've got a good agreement there.